Hi everyone, it's Miss Berlanga. In this video, I'm going to be explaining how you do speed and velocity calculations. We're going to see if you all can apply some of these definitions, these formulas you all have been learning about so far. You are going to want a sheet of paper, sheet of notebook paper, and a writing utensil. As you follow along these problems, I'm expecting you to sketch out the problems just like we've been doing before. I'm expecting you to attempt to do these calculations. You will also need either your copy of the annotated reading for lesson 4, or preferably get that science dictionary that we've been working on. So at this point, you should have completed the science dictionary lesson 4 assignment, which means that you already have all of the definitions and formulas for speed, velocity, elapsed time, for average speed, average velocity, and elapsed time. All right, so looking at this first example, Ms. Berlanga is walking down the hall. She starts out at her classroom and moves 5 meters to the right in 5 seconds. What was her elapsed time? So go ahead and pause this video, sketch out the scenario that you see here, right, including where I'm starting, where I'm finished. Again, remember, you can use either a dot or you can use a stick figure to represent objects on a number line, and then go ahead and write down those initial and final positions as well. So pause the video here, take 1 to 2 minutes to see if you can figure out what that elapsed time is. Again, refer to your science dictionary if you need to do so. All right, so you should have paused the video. You should have attempted to figure out what that elapsed time was. And so what we're going to do is we are going to assign an initial and final time here. So generally speaking, we are going to use t naught equals 0. That hit it for a second. So t naught, or the initial time, is going to be equal to 0 seconds the vast majority of the time, 99% of the time. Think about the fact whenever you start a stopwatch, you're timing yourself or timing someone do something, you're always going to start at 0 seconds. Then the final time is 5 seconds. So looking at that formula for elapsed time, remember delta t, or triangle t, just means change in time, and that is equal to the final time minus the initial time. And we can just plug in those times that we defined earlier. So 5 seconds minus 0 seconds. And then a number minus 0 is always just going to be that same number again. So the elapsed time is 5 seconds. Now keep in mind that you did not need to go through this calculation if you already knew that the initial time was 0. So in other words, the amount of time that it took to move was just going to be the time that was given in the problem. Another thing I want to point out is that you can write down elapsed time as delta t, which is that triangle t, or just as t. It's really up to you. Either way is fine. Again, keep in mind that annotated reading, we did both forms, so you can do either form that was in the annotated reading. All right, let's go ahead and move on to the next example. So this one right here, again, same scenario, but we are trying to find out what is the average speed. So going ahead and taking that same information that we had before and using that same sketch that you all had before, you do not need to draw a new sketch. You're just adding additional information about the scenario at this point. But you do want to go ahead and write down the initial time and final time if you did not already do so. So go ahead and pause the video right here and take about 2 to 3 minutes to see if you can figure out what the average speed is. Again, use your science dictionary, look at that formula, attempt to figure out the average speed. All right, so you should have gone ahead and attempted that average speed. And the first thing we're going to do is we're going to look at what we already know. So we know that the formula for speed is distance divided by elapsed time, or just time, depends on how you want to write it. We know that the distance covered in this problem, remember thinking about those definitions that we already used in the previous lesson, distance, displacement, position. We're continuing to use those and build on those. We can see that I moved a total of 5 meters. And for this quantity distance, we don't care about the direction, we just care about the length of the movement. So distance traveled is equal to 5 meters, or lowercase d is equal to 5m. And the elapsed time is just the same as what we already figured out. So we're just going to plug those numbers into this equation, 5 meters divided by 5 seconds. And voila, we get 1 meter per second. So that was pretty easy, right? Yeah, you got this. All right, we're gonna go ahead and move on to the final problem in this video. And now see if you can figure out what the average velocity is, okay? Again, look at your science dictionary, look at that definition for average velocity. Make sure that you are making that distinction between displacement and distance traveled. Remember, they're not the same thing. And go ahead and take about 2 to 3 minutes, see if you can figure out what that average velocity is. All right, so you should have attempted to figure out what that average velocity was. And again, we're gonna start by putting down what we already know. Now, we know that the formula for velocity is delta x divided by delta t. In other words, the displacement of the object or person divided by the elapsed time. Now, looking at this sketch that we did earlier, right? Remember that displacement is how far away you ended up from where you started and in what direction. So you need those two pieces of information. And this is super crucial because this is what makes average velocity different from average speed. It involves displacement, which is a position, okay? Totally different from distance. So if we look at how far away we ended up from where we started, I traveled 1, 2, 3, 4, 5 meters, and I ended up to the right, which is in the positive direction. That means that my displacement is positive 5 meters. So delta x is equal to plus 5 meters. The elapsed time, again, is just the same as in the previous two examples. And so knowing these two numbers, we can just plug them into our formula. And remember, when we write down displacement, we have to include that direction. That plus 5 is very important. We can't just write down 5, it has to be plus 5. So plus 5 meters divided by 5 seconds is equal to positive 1 meters per second. So my average velocity was 1 meter per second in the positive direction. So I was traveling 1 meter per second to the right. All right, guys, that is the last example in this check for understanding speed and velocity calculations. Now that you've done this, you should be more prepared to do your next assignment, which is the practice speed and velocity calculations problem set. Thanks, everyone. See y'all next time.